Now, in this video, we're going to take up one more problem on shaft. The problem number 17. It reads as, a hollow shaft is required to transmit 500 kilowatt at 100 RPM. The permissible shear stress in the shaft is 60 Newton per mm square. The maximum torque transmitted exceeds the mean torque by 15%. The internal to external diameter is 3/5. The angle of twist is not to exceed 1 degree in a length of 3.5 meters. The value of rigidity modulus is 80 kilonewton per mm square. Find the minimum external diameter of the shaft. So this is the problem which is given. So we will try to analyze the data now. Capital N is 500 kilowatt and small n is 100 RPM. And tau is given to be 60 Newton per mm square. And the maximum torque T max is 1.15 into T mean. And di by d naught is 3/5, which is equal to 0.6. And the angle of twist, that is theta, is 1 degree, which will be equal to 1 into pi by 180 radians. And the length is 3.5 meters, which is 3.5 into 10 to the power of 3 mm. And also capital G will be 80 into 10 to the power of 3 Newton per mm square. So therefore, these are the data which is given. So now I need to find out the minimum external diameter of the shaft, that is D naught. So to do that, since the power is given, so naturally we can determine the torque applied on the shaft. So the power transmitted by the shaft capital N will be equal to 2 pi n into T mean divided by 60,000 kilowatt. So you substitute the values of capital N as 500, which will be equal to 2 pi into small n is 100 into T mean, which I need to find out, that is 2 pi into 100 into T mean divided by 60 into 1000. So on simplification and cross multiplication, T mean will be equal to 47746.5 Newton meter. So therefore, the mean torque transmitted by the hollow shaft, which is T mean, will be equal to 47746.5 Newton meter, which will be equal to 47746.5 into 10 to the power of 3 Newton meter. So 47.75 into 10 to the power of 3 Newton meter. So if you want to convert that into mm, so it will be 47.75 into 10 to the power of 6 Newton mm. So now once we get the mean torque, so the maximum torque T max will be equal to 1.15 into T mean, which will be equal to 1.15 into 47.75 into 10 to the power of 6 Newton mm, which will be equal to 54.91 into 10 to the power of 6 Newton mm. So first case, the outer diameter of the hollow shaft based on the strength, that is maximum torque transmitted by the hollow shaft, which is T max, will be equal to pi by 16 into tau into d naught to the power of 4 minus di to the power of 4. Whole thing is divided by d naught and close the bracket. So that will be equal to pi by 16 into tau into d naught to the power of 4. You take out the common factor in the numerator into 1 minus di by d naught whole to the power of 4. So that divided by d naught. So d naught cancels, which will be pi by 16 into tau into d cube or d naught cube into 1 minus di by d naught is 0.6. So 1 minus 0.6 to the power of 4. So on simplification, so substitution, what you're going to do now, 54.91 into 10 to the power of 6 Newton mm will be equal to pi by 16 into tau is 60 into d naught cube into 1 minus 0.6 to the power of 4. So on cross multiplication and simplification, outer diameter of the hollow shaft, which is d naught, will be equal to 174.95 mm, which is approximated to 175 mm. So similarly, the outer diameter of the hollow shaft based on the torsional rigidity or torsional stiffness. So from the torsional equation, what we have, G into theta by L will be equal to T max by J. So since where J is the polar moment of inertia, which is pi by 32 into d naught to the power of 4 minus di to the power of 4. So substitute the values, that will be equal to T max, that is pi by 32 into d naught to the power of 4 into 1 minus di by d naught whole to the power of 4. So substitute these values, that is pi by 32 into d naught to the power of 4 into 1 minus 0.6 to the power of 4. Therefore, you will going to get the value of 54.91, that is T max by J. T 54.91 into 10 to the power of 6 divided by pi by 32 into d naught to the power of 4 into 1 minus 0.6 to the power of 4. So which will be equal to 80 into 10 to the power of 3 into 1 into pi by 180 divided by 3.5 into 10 to the power of 3. So on further cross multiplication and simplification, you will going to get the outer diameter of the hollow shaft, which is d naught, will be equal to 200.3 mm, which will be approximated to 200 mm. So similarly, based on the torsional rigidity, we have obtained the diameter of the outer diameter of the hollow shaft as 200. So in the outer diameter of the hollow shaft, if d naught is 175 mm, and considering both from the strength and as well as the rigidity criterion, so you will going to get outer diameter of the hollow shaft, which is approximated to 200 mm. So comparing between these two, select the bigger value, which is d naught will be equal to 200 mm, that is outer diameter of the hollow shaft, which is d naught, which will be equal to 200 mm. So inner diameter of the hollow shaft, which is di, will be equal to 0.6 into d naught. So 0.6 into d naught is 200, so it will be equal to 120 mm. So this is how you will be able to solve this problem. Thank you.